Hello everyone and welcome to this SolidWorks simulation tutorial. Today we have a case study. We will be running a static study on a stair bridge. So before we dive in, let's take a look at this guide we have here. It provides key details about the loads, interactions and constraints that we need to apply in our simulation. By the end of this tutorial, you will know how to set up static study, apply boundary conditions, and interpret the results. So without further delay, let's get started. So first we need to create a new study. We go to Add-ins, SolidWorks Simulation, and from the Simulation tab we have here so we choose a new study. We change the name to Stair Bridge. Okay, so first thing we need to define the material as specified in the guide. So we right click on the parts, select apply material to all bodies and search for alloy steel. We apply and close. Before we start applying the fixed geometry and all this, we can see that the blue components here are non-Lloyd bearing and won't affect the structure integrity in a significant way, so we can simply exclude them from the analysis. So to do this, we right click on each of these parts in the simulation tree and select Exclude from analysis. So we just exclude them one by one. This helps to reduce the meshing and optimize the calculation time. So after that, we need to define the interactions between components. The guide specifies that all parts should be bonded. We go to connections, component interactions. So actually, SolidWorks automatically applies a default global interaction to all contacting or touching components. By default, it's set to bonded. So as we can see, when we try to make a new, it shows global interaction is already defined on top level component. Okay. So since the structure is composed of beams, let's just make sure that SolidWorks treats the subparts accordingly. So it's treated as beams. Otherwise, we have to right click on each part and we would find here in place of treat as solid, treat as beam. So now let's move on to applying the boundary conditions. First, the fixed geometry. We fix the joints where the structure is attached to the ground to prevent any movement, just as it would be in real life condition. So then we apply the force. External loads, force. We select beams. So we select our beams here. And for the direction, I will just choose the edge here. Okay, we put 3000 newtons. The arrows here shows the direction of the force, so we need to reverse the direction and assign. Next we have to apply gravity. It's already defined. And finally we move on to meshing. Since we don't have any specification about the mesh, we just generate the mesh. Once everything is, we just need to run the study. And here we go. This is the behavior of our stair under the applied loads. So now we can respond to the questions we have here. First, we need to extract the maximum stress in megapascal, upper bound axial and bending with 3 decimal places. So we right click on stress, chart options. In definition, we change this to megapascal. And we select max annotation. We change the format to floating and we adjust the decimal places. Okay, so here we have the value needed, the maximum stress. For the displacement, we just do the same. We change the format and 3 decimal places. It's already in millimeter. And we have the value of the deformation. For the last question, we have to extract the stress at a specified node, node number 400. So to do this, we select stress, we right click and select probe at element number, and we enter the number of the node. And here we have the value of the stress at this node along with its position. That's it for today. We successfully followed the guide and ran the static study. So if you found this tutorial helpful, don't forget to like, subscribe and leave a comment. Stay tuned for more tutorials.